This is Cambridge IGCSE for Chemistry Paper 4, Theory Extended, Variant 2 for February-March 2016 version. Question 1. The table below gives information about particles. Complete the table. The first line has been done for you. First thing first, looking at the charge of the particle is -1. Since it has 18 electrons, that will mean that it has one more electrons than proton. So 18 minus 1 becomes 17. And then for C, it has 18 protons. And then the electron arrangement is 288, which means it translates to number of electrons. So 18. And then finally, there are 10 electrons for D. So it will be rearranged to 28. And then the charge of the particle depends on the number of electrons and protons. There are 2 more electrons and protons, creating a -2 charge. Question B. Gallium is a group 3 element. Define the term element. Now, you can define it in many ways. You can talk about substance that cannot be broken down into anything simpler. You can talk about like it's a substance that cannot be broken down by chemical means. You can also talk about, I would say, for me, my best version of the definition is that it contains, all right, substance that contains atoms with the same atomic number. All right, to me, I feel that this is the best fit, I would say best fit definition for elements. Right? Now, let's move on. The following are gallium atoms. Complete the following table. Now, first of all, you notice that there are 2 numbers in the symbol of the chemical. Now, the small number is the proton number, or also known as atomic number, so 31, 31. The number of neutrons can be found by taking the nuclear number, which is the large number written here, and minus the proton number. So 69 minus 31 gets you 38, whereas 71 minus 31 makes you 40. So 38, 40. And lastly, electrons. Now, since both of them are uncharged, it will mean that they have equal numbers of protons and electrons, right? Uncharged atoms have equal number of protons and electrons. So in that case, both of them have 31 electrons. Moving on, rubidium is a group 1 element. It has similar physical and chemical properties to other elements in group 1. Predict how many electrons are there in the outer shell of a rubidium atom. So group 1 means, well, 1 outer shell electrons. Predict 1 physical property of rubidium, which is the same as the transition element. Now, group 1 and transition element are both metals. So you will expect to know, you will know that both of them have metallic properties. Like, for example, conduct electricity well, right? They have good electrical conductivity or heat conductivity. They are malleable. They are ductile. They are also shiny. They are also sonorous, right? Which are typical metallic properties. Predict 2 physical properties of rubidium, which are different to those of a transition element such as iron. Now, in terms of that, right, group 1 has lower density, lower boiling point or melting point, and then it's softer. And also, I would say that the strength, right, is lower than a transition element. Okay, so let me write here. So rubidium has a lower melting point, lower density, softer, and is softer than iron, right? Okay, moving on. When rubidium is added to cold water, a reaction occurs. What 2 observations can be made when rubidium is added to water? Now, you may see an explosion because it is actually very reactive. It's more reactive than your lithium, sodium, potassium. You will also see bubbles, or we call it effervescence, call it fizzing. You also see flames, right? Flame. You also see that the solid moves, it dissolves, right? It floats in the water, right? Next, what would be the color of the solution if metal orange was added to it after the reaction? Now, this is a group 1 metal. It's also known as an alkali metal. An alkali metal means that it dissolves in water to form alkali. So in that case, metal orange will be yellow. And in fact, what's happening in the reaction, our rubidium is reacting with our water to form rubidium hydroxide solution and alkali, and in that process produces a lot of hydrogen gas. To balance the equation, there's, well, should be 2 water, 2 rubidium, and 2 rubidium hydroxide to balance the equation. Next, put the group 1 elements, cesium, lithium, potassium, rubidium, and sodium, in their order of reactivity with water. Put the most reactive element first. In that case, there will be our cesium first, cesium, followed by rubidium, followed by our potassium, then our sodium, and then our lithium. As going down the series, going down the group, it gets more reactive. So just one safety measure that can be used when rubidium is added to cold water. Well, you can use goggles, glasses, gloves, use a safety screen, safe distance from the chemicals, use tongs, do the experiment in an open space, and many, many more precautions that have to be made when you do this experiment. Next, the phosphate ion has the formula PO4 3-. Deduce the formula of rubidium phosphate. Rubidium is a group 1 chemical, so it forms +1. Phosphate is PO4 3-, so you swap and simplify. Rb3PO4. That's the formula of rubidium phosphate. Now, next question. Carbon dioxide and silicon dioxide are oxides of group 4 elements. Complete the following table. Now, formula for carbon dioxide is CO2. The physical state of silicon dioxide is a solid, as the melting point is way greater than the room temperature. And then for silicon dioxide, it is a non-conductor of electricity, whereas for carbon dioxide, it's a simple molecule, simple molecular structure, or you can call it a simple covalent structure. Name the type of bonds that exist between atoms in silicon dioxide. In atoms of silicon dioxide, it is the covalent bonds represented by the lines, all right, between the atoms, so covalent bonding. Explain why silicon dioxide has a very high melting point. Because, well, of the strong covalent bonds, right? Strong covalent bonds between silicon and oxygen atoms in the giant covalent structure. Hence, a lot of energy is required to overcome these strong bonds. Is required to overcome these strong covalent bonds. Explain in terms of attractive forces between particles why carbon dioxide has a very low melting point. It's due to, well, weak intermolecular forces between carbon dioxide molecules, all right, in the simple molecular structure. Hence, only a little, not a great amount of energy is needed. So instead of a lot, right, instead of a lot, it will be little. Only little of amount of energy, right? Only a low amount of energy is required to overcome these weak forces of attraction. Okay, sorry, weak intermolecular forces of attraction, to be having a full answer. All right, next, explain in terms of particles why carbon dioxide is a non-conductor of electricity. Because it lacks free moving ions or electrons. Or you can say that because carbon dioxide is made of uncharged molecules. Right? Next, suggest a chemical reaction between the reaction of sodium hydroxide solution and also carbon dioxide. Now, sodium hydroxide is an alkali. Whereas carbon dioxide is a non-metal oxide, which means that it is acidic. So we will expect to see, right, an alkali reacts with acid to form, a salt, right? I would say that there's a lot of course, there's maybe a fixed answer or in certain conditions, but the thing is we make a guess here. So it's maybe sodium carbonate is formed, right? Because I see there's carbon dioxide and then we have a sodium ion. So metal cation, I'm thinking of a carbonate possibility. And then that also forms water in the process, right? So let's balance the equation here, 2 sodium, then 2 sodium carbonate. Yeah, so sodium carbonate and water. Now, some students will think of sodium bicarbonate, which can be accepted as well. Sodium hydroxide reacts with carbon dioxide to form sodium hydrogen carbonate. That is possible as well. Next, name the type of chemical reaction in which carbon dioxide is produced from fossil fuels, in which, in that case, it will be combustion reaction that release, to be more exact, is complete combustion, right, that forms carbon dioxide. Name the chemical process in which green plants convert carbon dioxide into carbohydrate, which is photosynthesis. Really straightforward. Name the chemical process in which living things produce carbon dioxide, which is respiration. Relatively straightforward. Let's move on. Next, hydrogen peroxide decomposes into water and oxygen in the presence of a catalyst, manganese 4 oxide. What is meant by the term catalyst? It is a substance that increases the rate of reaction without chemically unchanged, right? Without it being chemically unchanged, sorry, without it being chemically changed, sorry. Or should I say, while it chemically unchanged? Without it being chemically changed, right? At the end of the reaction. Or you can say it is not used up. Now, you can also talk about like it lowers activation energy. Next question. A student studies the rate of decomposition of hydrogen peroxide using the apparatus shown. The student uses 20 cubic centimeters of 0.1 mole per cubic decimeters hydrogen peroxide and 1.0 grams of manganese 4 oxide. The student measures the volume of oxygen given off at regular time intervals until the reaction stops. A graph of the results is shown. When is the rate of reaction the highest? Well, at the initial 0 second. Okay, at the initial second, right, at the start, initially. Okay, you can say when it starts, or some students will say T equals to 0. Now, so just one method to increase the rate of reaction by using the same amounts of hydrogen peroxide and manganese 4 oxide. Now, I can crush the catalyst into powder, or you can increase the temperature of the mixture. All right. Next, calculate the number of moles of hydrogen peroxide used in the experiment. So it's given that we are using this amount of hydrogen peroxide. We're given the volume and also the concentration. So we use this, which is the mole of that will be concentration times volume, in which it is 0.1 times 20 out of 1,000, because the volume must be in cubic decimeters, and that will give us 0.002 moles. Moving on, use your reaction and the equation to calculate the number of moles of oxygen produced in the reaction. So here we found out that it is 0.002 moles. So which means that you make 0.001 moles, since it's a 2:1 ratio. And lastly, use this answer, find the volume of oxygen produced. It's a gas, which means that we have to use molar volume, which is 24. So volume is 0.001 times 24, gives you 0.024 cubic decimeters. Next, what will be the effect on the volume of oxygen produced if the mass of catalyst was increased? Now, that will have no change as you are not increasing the amount of reactants here. Deduce the volume of oxygen that would be produced if 0.2 mole per cubic decimeters of hydrogen peroxide was used instead of 20 cubic centimeters of 0.1 mole per cubic decimeters hydrogen peroxide. We are doubling the concentration, which means that we are doubling the moles. Right? We're doubling the moles. So in that case, you should form the double of your previous answer, 0.048, because you're doubling the mole of the reactant. Moving on, the student carries out a second experiment to investigate whether another substance, copper 2 oxide, is a better catalyst than manganese 4 oxide. Describe how the second experiment is carried out. You should clearly state clearly how you would make sure that the catalyst is the only variable. So this is our clue here. Okay, so I guess just use the same reaction, same conditions, which is same, 20 cubic centimeters of 0.1 mole per cubic decimeter of hydrogen peroxide, and then 1 gram of copper 2 oxide instead of manganese 4 oxide. Right, so same volume, same concentration, same mass of catalyst, and then maybe you can talk about the same temperature. Oh, they didn't say how to prove. So I guess that's it. Yeah, you're just stating all the control variables, which is 3 marks in total. Let's move on. This question is about compounds of nitrogen. Describe the Haber process giving reaction conditions in a chemical equation. Reference to the rate and yield is not required. Well, first of all, equation-wise, it's N2 plus 3H2, reversible reaction, form 2NH3G. All right, that's the equation. Okay, the conditions are 450 degrees Celsius for the temperature, and then 200 atm for the pressure. And then our catalyst is our iron, it's powdered iron. And actually that's it. It's 1 mark for the equation, 1 mark for the reversible symbol, 1 mark for 450 degrees Celsius, 1 mark for 200 atm, and 1 mark for iron catalyst. Next, usage of ammonia, you can use it to make fertilizer, right? Manufacture of fertilizer. Some students are even give more, they talk about make nylon, nitric acid, also urea, also used as an explosive. Of course, those are true, which can be accepted in the exam as well. Next, the diagram shows the structure of a hydrazine molecule. Draw the electron arrangement of a hydrazine molecule and show the outer shell electrons only. So we are translating the diagram into circles, right? Circles. So we do the same thing, right? We have right. So our central nitrogen atoms, and then our hydrogen atoms on the side. Each line represents a single covalent bond, which means a covalent bond, which means it is of 2 shared electrons. So 2 shared electrons with hydrogen, 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 and then here is 2 shared electrons with nitrogen between these 2 nitrogen atoms, and also there's more because nitrogen uses 3 of its outer shell electrons for bonding. Actually, it will remain, there will be 2 non-bonding electrons for each nitrogen atom. Since it's a group 5 element, 5 take away 3, left over 2. All right, so that's it. Next, hydrazine is a base. What is a base? It's a proton acceptor. and then complete the chemical equation to show that hydrogen acts as a base when added to water. So to show that it donates a proton, so what you do is you remove hydrogen, sorry, you, not proton donor, sorry, my bad, proton acceptor, you add a hydrogen ion, this one remove the hydrogen ion, so left over N2H5 plus OH minus. All right, moving on. Some students even give double dissociation, right? Which is some students give N2H6 plus and 2OH minus, which can be accepted as well. Right, let's move on. Nitrogen dioxide is an atmospheric pollutant. State one environmental problem caused by nitrogen dioxide. You can talk about it causing acid rain. And for some answers that can be accepted include photochemical smoke. Right, photochemical smoke. Right. Next, explain how oxides of nitrogen, such as nitrogen dioxide, are formed in the car engines. So the nitrogen and gas and oxygen gas from the air react in car engines due to high temperatures, which provide the activation energy required for them to react. Moving on, iron pyrite is known as fool's gold because it is a shiny yellow solid which is similar in appearance to gold. Iron pyrite is an ionic compound. Gold is a metallic element. Iron pyrite contains positive and negative ions. The positive ion is Fe2 plus. We use a formula for the negative ion. So Fe2 plus, we have FeS2. So reverse engineer. This one is plus 2, so this one must be minus 1. Plus 2, this one must be minus 1. So our formula is S minus. Right, S minus. A student is provided with a sample of iron pyrite and a sample of gold. Suggest how the student can distinguish between the two substances. Given one is an ionic compound, the other one is a metallic element, it means that they will exhibit different electrical conductivity. All right? Or actually, there are many ways to determine. Okay, I would say for me, I'll choose this one, which is take the solid, right? The solid state of both items, of both iron pyrite and sample of gold, right? And then I'll just connect it to wires and see if it conducts electricity or not. Right? So our goal will be able to conduct electricity in solid state. All right, because if you remember about the theory, it has free moving electrons in the structure. But for our iron pyrite, since it's an ionic compound, it wouldn't be able to conduct electricity in solid state. It will only be able to conduct electricity in aqueous or in liquid state. Okay, so in that case, I'm able to differentiate these two. Now, other answers include, of course, think about metallic property compared to an ionic property, such as malleability, right? Malleability, right? So our gold will be more malleable. Iron pyrite will not be malleable. Maybe talk about the density as well. Density will be greater since gold is very dense. You can also talk about like adding acid, right? Because acid actually it has to be a specific acid. Yeah, it has to be a specific acid, like concentrated hot nitric acid. Okay, because gold is actually not so reactive. It's less reactive than hydrogen, so you need a very strong oxidizing acid, which is actually I think most students don't know for this syllabus. But some students manage to talk about that in the mark scheme, and then you can talk about maybe heat in oxygen, right? Heat in oxygen. You can talk about also in terms of heat with a more reactive metal. All right, heat with a more reactive metal, in which this will allow a displacement reaction to occur. Because those which are more reactive than iron will be able to displace it, but then this is not a compound, it couldn't be displaced per se. So there are lists of answers possible here, but for me, I think this one most students will be more aware. Okay, moving on. Sulfur dioxide is produced on a large scale by heating iron pyrite strongly in air. The iron pyrite reacts with oxygen in the air, produce iron trioxide and sulfur dioxide. construct a chemical equation for this reaction. So our iron pyrite plus our air means oxygen form our iron trioxide and then our sulfur dioxide. Okay, let's test around the idea. Test around first. We have two iron, three oxygen, two ions. Sorry, I need to put let's test with two and three. So I realize I have six oxygen. Six oxygen. I have four iron. So let's place a four, and it will mean that I have eight sulfur, which also means that okay, it seems that I have a lot to think about. Six oxygen, 14 oxygen, sorry, 16 oxygen, and let's reverse engineer back. It means that this number must be 11, not 3, 11. Okay, double check everything, should be fine. Okay, let's do it again because it's, to most students this is very challenging. Okay, my thinking is like this. How do I balance it out? I will think of the element that occur only once. In that case, is our iron and sulfur, right? Iron and sulfur. So I can try to put a 2, I can try to put a 4, but then I realize that it doesn't really work, right? It doesn't really work unless I actually put a 3 or 2, right? 2, 3, because it's the lowest common multiple of these two will be 6. Right, so I try to put a 2 here, I try to put a 3 here, then I realize that I need to put a 4 here, like 2 here, no, 4, my bad, 4 here, then 8, which means I have to put an 8 in front of SO2. Then in total, there will be 11 oxygen. So that's how my thought process goes, is try and error until I get the actual equation. All right, next, give one use of sulfur dioxide, so use in contact process. Right, contact process. So some students will talk about bleaching as a food preservative, all right, that is also applicable. Move on. Alkenes are examples of hydrocarbon. What is the meaning of hydrocarbon? A substance that contains only hydrogen and carbon. Give the general formula of a straight chain alkane. So CnH2n plus 2 for alkane, and then for alkene is CnH2n. Moving on, a compound X contains carbon, hydrogen, and oxygen only. X contains 54.54% of carbon by mass, 9.09% of hydrogen by mass, and 36.37% of oxygen by mass. Calculate the empirical formula of compound X. So first, we have to identify the mass ratio of the substance. In that case, we are given is 54.54% by mass for carbon, 9.09 for hydrogen, and 36.37 for oxygen. Step 2, we have to find the mole ratio. To convert mass to mole ratio, all we need to know is that we have to convert it by dividing by molar mass of individual elements. In that case, it's 54.54 divided by 12, 9.09 divided by 1, 36.37 divided by 16. These are relative atomic mass of the individual elements, which then you found that it is equal to 4.5. This is equal to 9.09, and this is equal to 2.27. So then the next thing to do is that we have to simplify the whole number ratio. So that can be done by dividing by the smallest number in the out of the three, in which it is 2.27, which will give us a 2 is to 4:1 ratio. So the empirical formula is C2H4O. Next question. Compound X has a relative molecular mass of 88. Deduce the molecular formula of compound X. So in that case, we have to figure out the n value, since our mass of the empirical formula multiplied by n is equal to 88, right? Which is in which we need to find the mass of C2H4O first, which is 12 times 2 plus 4 plus 16, then times n equals to 88. So n equals to 88 divided by this sum, in which if we try to calculate, it is 44. So n is 2. All right, so in that case, we substitute it back to our molecular formula. Our molecular formula is C2H4O times 2, which makes C4H8O2. Next question. An ester has the molecular formula C3H6O2. Name and give the structural formula of two esters with the molecular formula C3H6O2. So we have two options. Either we have a methyl ethanoate or an ethyl methanoate. So methyl is CH3 and then followed by an ester functional group, and then this component has 2 carbon. And then our ethyl methanoate is, we have C2H5 followed by ester linkage, and then this one only has 1 carbon. Right, first name alcohol, second name carboxylic acid, 2 carbon. First name alcohol, second name come from the carboxylic acid. Okay, moving on. Name the ester produced from the reaction of propanoic acid and methanol. So first name alcohol, methyl. Second name carboxylic acid, propanoate. Next, a polyester is represented by the structure shown. What is the type of polymerization used for the production of polyesters? Because that removes a small molecule during the formation. So this is called a condensation polymer. Excuse me. And the simple molecule removed is water. Now, to draw the monomer, simply place back water molecules. So we copy the structure first. And then what we do is we fill it in with our water, so which is H2O. This comes from the carboxylic acid because it's an ester. This comes from the alcohol, so OH, OH. Right, ester are formed of carboxylic acid and also an alcohol. Moving on. Oh, that's the end of the paper, right? So hopefully it's okay. And I hope to see you in the next one. If you're struggling in IGCSE Chemistry, you can feel free to visit our website and see how we can do to help you. If you're struggling by your own, I would say you can try to seek for us for professional advice. Okay, I think that's it. I'll see you in the next one. Bye-bye.